let's see how this does. So when we were factoring this, we were looking at doing this type of problem where we take the first number times the last number. In this case, it would be 1 times 36. That would give us 36. And then the middle number in the bottom.
Is this a warm-up?
No. I'm just reviewing from yesterday. And then what times what gives you 36, but adds or subtracts to get negative 15. And the first thing I do is just have some guesses. So I'm going to say, here are my guesses. And I think 6 times 6 first. But if I add these together, I get 12. If I subtract them, I get 0. So nothing close to 15. So that doesn't work. Then I start just using my calculator. And I start with 1 and 36. I know that's not going to work. If I add or subtract those, I get 35 or 37. 2 and was that 18? Right? 36 divided by 2, 18. That doesn't work. If I subtract 18, 17, 16, it's close, but it doesn't work. What about 3? 36 divided by 3. That's 12. And this does, if I add them together, I get 15. Do we see the guessing process for that? And then you could just use your calculator by dividing or whatever. So I have 3 and 12. That works, except I need both of them to be negative. Because when I add them together and they're both negative, I get a negative 15. And when I multiply two negatives, I get a positive 36. So that works out. And then the shortcut is just to write x minus 3 and x minus 12. So that was that one. We also did something like this, where we had the same thing, except for when the first term was negative, we would divide by a negative, or a negative 1. So when first term is negative, divide by a negative. So I'm going to divide by negative 1. Then whatever I'm left with goes on the inside of the parentheses. I'm just changing all of these signs then. Plus 13x plus 22. And now I use my x on this. So in the top, 1 times 22 is 22. In the bottom, I have 13. My first guess is, 2 and 11? Is that what? 11, 12, 13. Yeah, 2 and 11 work. And if I add them, I get a positive. When I multiply, I get a positive. That works out. X plus 2, x plus 11. So that's the answer for B. Questions on that? That's all we were doing yesterday. We're going to do this today and this part, except for instead of a negative, it's going to be other terms, other numbers, or other variables. So it's basically nothing different than that. So, like the real example 1. We'll say just factor. It might mean divide by the greatest common factor. It might mean use the x method. It all is factoring anyway. So you just have to figure out what you have to do. So if I had 9x squared plus 18x minus 18, I can't use the shortcut on this because This is not just a 1. I cannot use the shortcut. I can't just jump to something like this after I do the x, because this has a 1, so I could. This does not have a 1. But what could I do on this? Yeah, you could divide everything by 9. That's the greatest common factor there. Whatever you divide by goes on the outside of the parentheses. And then you're left with x squared plus 2x minus 2. And then what do you think you could do? Yeah, we can use the x method or x factor, however you want to call it, because now this has a 1 there, and we can use the shortcut. So let's try that. I would have a 1 and a negative 2, so that's negative 2 on the top. We're combining them, yes. We're combining the two things that we've been doing. So if I have the negative 2 and then a positive 2, what times what gives you 2? So let me write down my guesses. Well, 1 times 2, that's it, right? If I add these together, I get 3. And if I subtract them, I get 1. So this doesn't work. So that means we've factored as much as we can. So when it doesn't work out for this, and you've written out all the guesses, and none of them work, then you can't factor this anymore. This is considered a prime polynomial. That just means you can't factor it. Already factored as much as possible. So sometimes you run into stuff like that. But other times, you can just keep going. I think I have one more example, unless you want more than that. But let's see. Are there any questions on this one? Does anyone still need to see this? No? Okay. Let's see this. So if I have the instructions factor, and we get 4x cubed plus 20x squared minus 24x. What can we take out of this? 4 and an x, because everything has at least one x. So we can divide by 4 for the numbers, and x for the variables, because x is the smallest, x to the 1 is the smallest exponent that we have. Whatever you divide by goes on the outside. And we're left with 1x, or just x. Sorry, x squared, thank you. Right? X to the third divided by x is x squared. And then plus 5x minus 6, and the x's go away. And then now we can do the x method on this. Negative 6 and 5. I think we did this one yesterday. I could do 3 and 2. They add together. So here's what I'm trying first, actually. If I did, you don't have to write this down, but if I did 3 and 2, I need one of them to be negative. But then as soon as I make the 3 negative, now they add up to negative 1. So actually 3 and 2 doesn't work. So I'm going to try 1 and 6. 1 and 6. I need one of them to be negative. If I make the 1 negative, then yeah, it adds up to positive 5. So,
We would end up just as x minus 1, x plus 6.
well, x minus 1, x plus 6, and then the 4x. You can't forget that part. If we were to use the box method on this and then distributed the 4x, we should get back to our original problem, because factoring is the reverse of multiplication. Any questions on this? Do you want to see another example, or do you think you're okay? Okay. Factoring, I think, is one of the most important things, because you're always going to do it. If you take further math classes, you're always going to be factoring. So we're going to spend a lot of time on the different types. We're going slow, though.